let's explore multiplication and division. If we take 3 and add another 3 and another 3 and another 3 and another 3, then we have 1, 2, 3, 4, 5 lots of 3, which we can write as 5 multiplied by 3. But we can just as well see that as 1, 2, 3 lots of 5. So 5 times 3 is the same as 3 times 5, and in both cases you have the answer of 15. Now if we start with 5 multiplied by 3, what does this mean? It means we've got 5 lots of 3, or again we can see it as 3 lots of 5. But we can also then view this from a division point of view. So what we've got in each of those cases is 15 yellow dots. And we can see that if we take the 15 yellow dots and we ask ourselves how many groups of 3 do we have in them, the answer will be 5. In other words, if we do 15 divided by 3, we'll get the answer of 5. Because 15 divided by 3 asks us how many groups of 3 are there in 15? And there are 1, 2, 3, 4, 5 groups of 3 in 15. So, knowing that 5 times 3 is 15 also immediately tells us that 15 divided by 3 is 5. And similarly, we can also see that 15 divided by 5 will be 3, because we're asking how many groups of 5 are there in 15, and there are 1, 2, 3 of them. So multiplication and division are related. So for example, if I know that 23 multiplied by 12 gives me 276, so 23 multiplied by 12 gives me 276, I can immediately know some division facts from it. I know immediately that 276 divided by 12 is 23. And I'd also know that 276 divided by 23 is 12. Okay, let's just look at the language we use here. It's 276 divided by 12 is how we say that. And what we're asking then is how many 12s are there in 276? And another way we can express that is also to say 12 divides into 276 with no remainder. So just some of the language there. And then just a quick note on different ways we can write division. So there we write it very nicely. 276 divided by 12 is 23. But we can also write division as a fraction. So that fraction line means division. So if we see 276 over 12, what we're asking ourselves is how many 12s are there in 276? In other words, 276 divided by 12. And then finally with multiplication, and this will be far more so when we get to algebra, but in this case, for example, if you just see 23 and then the brackets 10 plus 2, it means 23 multiplied by 10 plus 2. And you'll see this a lot in algebra, that we often don't write the multiplication sign in. And so you know that if it's not there and you just go straight to the bracket, it means multiplication. Algebra is a language, and we need to know some of the basic rules of how to communicate using this language. Some of these are just conventions that make sure that we can all understand each other and that we're using the same signs to mean the same things. So let's first look at something like 3x, which you'll see a lot of in algebra. What this means is 3 multiplied by x. So in algebra, we very frequently do not write the multiplication sign, and we simply write 3x to stand for 3 times x. You would have a similar thing too if you wrote, for example, 2x plus 4. This means 2 times x plus 4. A very different story to 3x is x cubed. X cubed, that exponent means that you've got x times x times x. X multiplied by itself 3 times. Now, related to both of these is the idea that with 1, we often don't write it in algebra. So, 1x, we could write that. It just means 1 times x. But the convention in algebra is that we simply write x. So if you see x just like that, it means 1 times x, one lot of x. And similarly, we don't bother to write x to the power of 1 because x to the power of 1 would mean just, like x squared means x times x, x cubed means x times x times x. X to the power of 1 means you've just got 1x, and so it's just x that we write it as. If you have something like 6b times a minus a, this 6b times a needs to be done first. Now, you can't actually do very much with that, except in algebra we tend not to write the minus sign. So we could just write that as 6ba minus a. And then most people like to, for conventional algebra, to put their letters in alphabetic order. So instead of saying 6ba, it's just a bit prettier to say 6ab minus a. And say we had something like 3 plus p times 5. Again, we have to do multiplication first. So we could write this as 3 plus, and we could write p5 because in algebra we don't write the multiplication sign. But also in algebra, where we have a letter and a number, we prefer to put the number first. So we'd rather write it as 3 plus 5p. And more often than not, we will start off with the terms that have got letters in them before we write numbers. So none of these are wrong. These are perfectly decent. But this is the most conventional way to express it. If you have something like this, where you've got a with negative b in brackets, what you mean is a multiplied by negative b. And you can actually write that more nicely as you've just got a times b, and it has to be negative. And so it will be nicely written as negative ab plus 10. All of these that I'm showing you here are just conventions so that we all write algebra in a similar way. As I said before, these other ways of writing it are perfectly understandable. We can read them, and so they're fine, but they are just the more conventional ways of writing things in algebra. We're going to have a look at some properties of multiplication and division. If we want to do these, let's just think again about what multiplication is. If, for example, we wanted to do 3 multiplied by 6, what we'd be thinking of is that we've got 3 bags, each with 6 sweets in each bag, and so 3 multiplied by 6 will be 3 bags of 6 sweets, so in total we'll have 18 sweets. So 0 multiplied by 6 will mean we've got 0, no bags. Well, how many sweets will we have if we've got no bags? Well, we've got no bags, so we've got no sweets. So 0 multiplied by 6 will be 0. 1 multiplied by 6, well, it's just 1 bag with 6 sweets. So in total, we've got 6 sweets. Multiplying by 10 is always easy. 10 multiplied by 6 is just 60. And we can use this then to help us do other multiplication easily. So 700 times 60, we can start by saying we know 7 6s are 42. But we didn't want to just multiply by 6, we wanted to multiply by 60, so it'll be 420. And we didn't want to just multiply by 7, but by 700, so I have to multiply by 100, and we'll get our answer of 42,000. Now we want to see how we can also think about division as sharing, and this will help us to do some calculations. So if we've got 12 cakes and we want to share them equally between 3 people, we can do that. And we can see that 12 divided by 3 is 4, which we can also write in its fraction form. 12 over 3 is equal to 4. Now, how does that help us? Well, thinking about division as sharing helps us in the following way. If we're asked the question, is 4 divided by 3 or 4 divided by 5 bigger? It's easy to answer because 4 divided by 3 is just 4 cakes shared between 3, and 4 divided by 5, well, there you've got 5 people to share those cakes. Which is going to have more? Well, obviously, if you've only got 3 people sharing the cakes, you're going to get a bigger slice of cake each. So 4 divided by 3 is bigger. So we can summarize this by saying if we've got 4 and we divide it by a big number, we'll get a small answer, which we can also write in the fraction form. Making sense of it? 4 cakes shared between a big group of people will mean that everybody only gets a really small slice. And if the crowd of people gets bigger, the slice of cake everybody will get will be smaller. So then we can answer a question like this easily. 6 divided by 68, 6 divided by 34, which is bigger? It'll be 6 divided by 34, because there you've only got 34 people sharing the cake rather than 68 people sharing the 6 cakes. 0 divided by 6, well, that means we've got no cakes and 6 people want to share them. Well, if you've got no cakes and 6 people are sharing them, how much are they going to each get? Well, they're each going to get nothing because there are no cakes for them to have. 6 divided by 1, well, we've got 6 cakes and we've got 1 person who needs to share it. Well, that 1 person only has themselves to share it with, so they're obviously going to get all 6 cakes. And that'll be true for any number, right? Any number divided by 1 will just give you itself as the answer. 6 divided by 6, well, that's obvious. It's 1 because you've got 6 cakes, 6 people to share them equally. Everybody's just going to get 1. 6 divided by 0 is a funny one because what you've got there is you've got 6 cakes, but you've got no people. And so you're asking yourself, how much cake will each of the no people get? It really doesn't make sense. And so the answer there is undefined. Now let me give you a slightly more proper reason why it's undefined. We know division and multiplication are related. So asking yourself 6 divided by 3 is what is the same as asking what times 3 is 6. So, 6 divided by 3 is 2 because 2 times 3 is 6. Nice and simple, right? So if we're now returning to our question of dividing by 0, asking 6 divided by 0 is what is the same as saying what times 0 will give you 6. And here's where we're going to see there's a massive problem. So let's imagine we try 6 divided by 0 is 0, say. Well, that would mean that 0 times 0 would be 6, but that's not true. All right, maybe 6 divided by 0 is 6, but then 6 times 0 would have to be 6, and that's not true either. And so no matter what we try to put in place of that question mark, it's just not going to work out, because anything multiplied by 0 is not going to be able to get you 6 as the answer, because anything multiplied by 0 is 0. So there's nothing we can put in the place of that question mark to make it work. And so 6 divided by 0 is undefined. Let's have a look at some more properties of multiplication and division. We know that something like this is just 6 lots of 3. So 6 multiplied by 3. But we can see that as being made up of 4 lots of 3 plus another 2 lots of 3. Working purely symbolically, we can see this as 6 multiplied by 3. Well, 6 is 4 plus 2. So we've got 4 plus 2 multiplied by 3. And that means that the 3 needs to multiply with the 4 and also with the 2. So we've got 4 times 3 plus 2 times 3. And that is going to give us 4 times 3 is 12, 2 times 3 is 6. So 6 times 3 is going to be 18. What we have here, the fact that the 3 needs to multiply with the 4 and also the 3 needs to multiply with the 2 is known as the distributive law. Another law we can look at is as follows. Let's look at if we have 2 multiplied with 4 times 3. Well, that means we've got 2 lots of 4 times 3. What does 4 times 3 look like? Well, 4 times 3 is 4 lots of 3. And we've now got 2 of these, 4 lots of 3. So we've got 2 lots of 4 lots of 3. And so we can see quite easily from that picture that what we've got is 8 lots of 3. But 8, we know that 8 is just 2 times 4. And so what we've got is 8 is 2 times 4 times 3. What we're seeing here is it doesn't matter the order in which we do this multiplication. We can do 2 multiplied by 4 times 3, or we can do first do the 2 multiplied by 4 and then multiply it by 3. This is called the associative law. How do these laws help us? Well, let's consider something like 12 times 7. Imagine we didn't know our 12 times table. So what we can do is remember that 12 is made up of 10 plus 2. So then we can say that 12 times 7 can be got by saying 10 times 7 plus another 2 lots of 7. And so it's going to give us 70 plus 14, which is 84. Imagine we couldn't do 8 multiplied by 6. Well, we know that 8 is 2 times 4. So what we've got here is 2 times 4 multiplied by 6. Now we might know what 4 times 6 is. And because of the associative law, we can say 2 lots of 4 times 6. And we know 4 times 6 is 24. So this is 2 lots of 24. And doubling 24 is really easy. The answer is 48. So that's using the associative law. A few more examples. If we were trying to do something like 16 times 23 minus 6 times 23, well, we actually can just reverse the distributive law here and see that what we've got is we've got 16 lots of 23 and we're taking off 6 lots of 23. So what we're going to be left with is 10 lots of 23, and that is going to be 230. Now let's say we're given a fact like 18 times 26 is equal to 468. Can we use that to work out the next lot? Well, the first question is, what is 468 divided by 26? And that should be very easy to answer. We know about the relationship between multiplication and division, so immediately we'll get our answer of 18 here. But now what if we were then to divide by 468, not by 26, but by 52? Now hopefully you're immediately noting 52 is just double 26. Now this is where I actually find it quite useful to write things as a fraction, because division as fraction, because it helps me to see what's going on. I'm trying to do 468 divided by 52, right? And I notice immediately that my 52 is just 26 multiplied by 2. I know that if I do 468 divided by 26, I'm going to get 18. But you see I still have to divide by 2. So 18 divided by 2 gives me my answer of 9. All right, what about 18 times 13? Well, here I'm noticing that I had 18 times 26, and now I'm going to 18 times 13. 26 is double 13, or 13 is half of 26, right? So 18 times 13 is just going to be half of 468, which is going to be 234. And then the very last one, 19 times 13. Well, I know that if I had 18 lots of 13, so 18 bags with 13 sweets in them, I'd have 234 sweets. So what if I had 19 bags now? Well, I've just got one more bag of 13. So I just need to add 13 onto 234, and I will get my answer of 246. 7.